Okay guys, today we are going to solve inequalities. These should be just a review from Algebra 1 and Algebra 2, so it shouldn't be anything too new. But before we do that, we need to go back to the last notes when you did the inequality notations, and it was brought to my attention that I made a little mistake. On this example here, this is a bracket because it's closed in, but I didn't put the line underneath here. So go back to page 92 in your notebook and make sure that you have greater than or equal to -2 on that one. Okay? Now, for today's solving inequalities. On the first thing here, it says on the number line above, drawing the values less than 3. So for inequalities, we don't just have one answer, we have several answers. So less than 3 means that everything less than 3. So I'm going to color this all in so you can see it good. And then at 3, we're not including 3 because it just says less than 3. So everything less than 3. Okay, so inequalities are a set of numbers, not just one number for an answer. The first question here is what is different about solving an inequality than an equation? Well, the first thing that is different is that when you solve an inequality, if you multiply or divide by a negative, you have to flip the inequality. If you multiply or divide by a negative, you have to flip the inequality. So if you have something like -5x is greater than 20, when we divide by -5, we have to flip this inequality from greater than to less than. Okay? And the second thing is that x, or whatever variable you have, your variable needs to be on the left. Your variable needs to be on the left, and that is so that we graph the right way. So the inequality that we have up there at the top, if it was written like this, 3 is greater than x, then when we go to graph that, we might shade the greater than way instead of the way that it should be. So this needs to be flipped to where it's x is less than 3. So then we have the sign going the right way, and we'll shade it the right way when we graph it. So that's just so that we shade it the right way on the number line. So just make sure that, for example, this one is pointing to the x, so it's pointing to the x when you flip it. So those are the two things that are a little bit different than solving an equation. So for the rest of these examples, we're just going to go through working them out, and they'll start off easy and get a little bit harder as we go along. But the first one, 3 minus 2x is less than 11. This is just like your equal sign that divides it into the two sides. So we want to subtract 3 from both sides. So we get -2x is less than 8. And keep your inequality all the way down so you don't mess it up. Now here we subtracted 3, and that's fine. We don't have to change anything. We can subtract and not change anything that we do. But now on this step, we have to divide by -2. When we divide by -2, that goes back to that rule where if we divide by a negative, we have to flip this inequality. So instead of less than, it's now greater than. 8 divided by -2 is -4. So x is greater than -4. And it says to give your answer in interval notation and to graph it. So interval notation, I think it's easier to graph first. So if you look at this on a number line and we graph it, and we can be a little lazy if we want to and not draw the whole number line. If this would be an open circle, it would be at -4, and it's going greater than, so that's our graph. I think it's easier to graph it, then you can look at it and it makes the interval notation easy. We're going from -4 to infinity, so we're going -4 first, always go left and then right, so -4 to infinity. Remember from our last lesson, infinities always get parentheses, open circles get parentheses, So this is interval notation from -4 to infinity. Okay. Number 2. This one we need to get our x's together. So normally we always say to get your x's, go to the bigger one, and 1x is bigger than -2, but we have to end up with our variable over here on the left, so I'm just going to move my variable to the left. So if I subtract x, I get -3x minus 4 is greater than 5. Then I want to add 4 to both sides. So -3x is greater than 9. Divide by -3. And again, we're dividing by a negative, so we have to flip the inequality. So x is less than -3. So our circle is going to be at -3. The less than shades to the left. So that's our graph. And so remember, this way is -infinity. So left to right, we have -infinity on the left. So when we put it in our interval notation, that's what goes first. And then we're to -3. And they both get a parentheses again. Okay. Next, number 3. 8x plus 45 is, or 18x plus 45 is less than or equal to 12x minus 8. So move our x's, we get negative minus 12x here. So 6x plus 45 is less than or equal to -8. Subtract 45. And 6x is less than or equal to -53. Divide by 6, and we have x is less than or equal to -53 over 6. Now normally, I just always leave them like this. But since we're graphing on a number line, we need to know what number that is. It really doesn't matter if we're just doing our little arrows, but if you're actually putting this on a number line, you would want to know exactly, what that is. So if we divide it, x is less than or equal to -8 and 5/6. That's why you should use a pencil. So -8 and 5/6. So we're going to have a dot, -8 and 5/6. It is less than or equal to, so it's going to go to the left, and it's going to be shaded in. Okay. On interval notation, on the left side is negative infinity. It's going to -8 and 5/6. Infinities always get a parentheses. Since this is colored in, it's going to get a bracket. Okay. Sorry about the smudgy stuff. Our copier does that sometimes. Okay, number 4. Now this one has a fraction. Up till now, all of these are pretty easy ones that you've done all through your algebra classes. This one is still fairly easy. We did a few lessons back. We were doing equations that were rational, and we talked about then getting rid of the denominators. So here we have a common denominator of 12. So in order to get rid of that denominator, I'm going to multiply both sides by 12. So when I multiply both sides by 12, technically what I do is I distribute this 12 to both of these. So I'm going to write a 12 here, and then I'm going to put a 12 here just so I don't forget. So when I divide here, 6 will go into 12 2 times. So that means I have 2 times 4x minus 3. Here there's nothing to divide by, so it's just 12 times 2. Greater than or equal to. Here our 12s cancel out, and we just have 2x minus 1. So now we have a nice, fairly easy inequality to solve with no fractions in it. So just work that out, and it would probably be good practice for you to pause the video and work it out, and then come back and check and see if you got it correct. Okay, these two are on the same side, so we're going to add them together. Subtract 2x to move it. So 6x plus 18 is greater than or equal to -1. Subtract 18. So 6x is greater than or equal to negative 19. Divide by 6. And x is greater than or equal to negative 19 over 6. So that would be our answer. So on a number line, normally if we had a number line, we would need to know where that is. So if you divide that out, 6 would go into 19 3 times with 1 left over. So x is greater than or equal to negative 3 1/6. So we have negative 3 1/6. Greater than, our arrow is going to go to the right. Equal to, our circle is colored in. So this is negative 3 1/6 on the left, going to positive infinity. Infinity always gets the parentheses, and the colored in circle gets the bracket. Okay. Now, number 5 is still fairly simple, but just a little bit longer. So again, you might want to pause and work it out, and then come back and see how you did on it. So we want to distribute. 6 times x is 6x. 6 times negative 1 is negative 6. Remember, if there's a negative in front of parentheses, that means that you have a negative 1 there that you're going to distribute. So that would give you negative 4 plus x is greater than or equal to 7x minus 8. Combine like terms. 7x minus 10 is greater than or equal to 7x minus 8. When I subtract 7x from both sides, it cancels on both of these. So now we don't have any variables. So this is just like you had in equations that you've worked out before. You have negative 10 is greater than or equal to negative 8. Now, is negative 10 greater than or equal to negative 8? Well, sometimes with negatives we get a little confused. So remember, if we had this on a number line, here would be negative 8, here would be negative 10. This is the bigger side, so negative 10 is not greater than negative 8, so this is a false statement. Okay, if everything cancels and you get a false statement, just like with equations, your answer is no solution. If they cancel, you may want to put you a note somewhere here in your notes. If your variables cancel out and you had a true statement, then it is all real numbers and anything would work. Okay. So let's go to a word problem here, an application. The percentage P of U.S. voters who used punch cards or lever machines in national elections can be modeled by the formula P equals negative 2.5x plus 63.1. So this is our equation, where x is the number of years after 1994. In which year will fewer than 38.1% of U.S. voters use punch cards or lever machines? You all probably don't even know what that means. But back in the golden days of when I first started voting, we had little machines where you would vote and then you pulled down this lever and it made all this noise, and it was really kind of fun. Now you just push buttons on a screen. But so we'll see when fewer than 38.1% of the voters should use the punch machine. So that